Hey, workshop students, I got to thinking about when I worked through these examples here, I got fixated on this equation, and my focus was on showing you that you've got, 4 knowns and then a total of 6 variables, and so you can just plug them in and solve. And I kind of overlooked maybe the easier, obvious step for number 3. So I thought I would kind of redo number 3. There's another way of looking at it, because notice this equation says this is equal to the net force in the x direction. And I just focused on this half of the equation, but let me focus on the other side here. So if I write this as F net in the x direction equals, and I just put these in because these are the 4 things that are known, F1, F2, theta 1, theta 2. Then we don't even have to worry about that complication of what the angle is. See, let me show you. And so I kind of regret not doing it that way because it's so much easier. But on the other hand, it was kind of nice to see that kind of more general picture that, hey, we got to do our trig functions. We got to watch out that there's always 2 answers in an inverse trig function. But let me just go ahead and set this up. So this would be 185 times the cosine of 165 plus the 345 times the cosine of 283. And those are just straight up given. So I could just put those into my calculator here. 185 times cosine of 165, add it to 345 times the cosine of 283. And that gives me my x component right from the get-go. And, oh, and I guess we already did this. Where are those sheets? It's right there. Yeah, so we really already did that. That was the x component. And with that matter, let me not take the time, but just go, okay, this would be the y component. So net force y component would be a negative 288.3. Okay, so I did all that at the very beginning, and then I started jumping into solving for the 2 unknowns. But maybe what I really should have done is then pause and say, if you look at just this being the x component and the y component, you can see that it's saying it goes in the x direction negative and also in the y direction negative, and that's how we know the angle would be in that 3rd quadrant. And that might have been an easier way to say then we know it needs to be, the 250-degree angle that we talked about in the last video. But we don't even need to know that, and that's what I should have pointed out. We could then just say, look, we have the x component, so if we square that, and then we take the y component and we square that, we get the total magnitude squared. And that avoids the angle altogether, and that would be a better approach for number 3, because number 3 never asks us to find the angle. And so I should have just put in the negative 101.1 and squared it, and the negative 288.3 and squared it, and got the force squared. And then just with a couple of steps in my calculator, I would be done. I wouldn't have to go through any of the trig stuff. So I'm kind of glad I went that longer way, because it showed some, that more general principle. Hey, substitute it in and then just go through the math. But I went in a direction that made us find the angle first, and then that led into a more complicated discussion of our trigonometric functions and how they're periodic. And so, like I said, it's probably good that you see that, but it's also probably good that you do things the shortest and simplest way. And therefore, I thought I better supplement this with saying, okay, wait, there's a lot easier way to get just the net force. And so putting in a couple of buttons here into my calculator, I get right to the answer of 305.5. And that is, I believe, what we got before. What did I do with those papers? Let's see. Let's see, that was number 4. Maybe this is it. Okay, that was part of the discussion of number 3. Yeah, so there it is, our discussion of number 3, and how we got the angle. And then once we got the angle, we had a discussion of what it would be, and we got the 306. So it matches. All right, thought I'd add that to the little video. All right, take care.